Hello friends, my name is AJ and welcome back to another AP Computer Science in-depth review video. Now, I recorded all of the in-depth unit reviews for Units 1 all the way through Unit 10, all the units for AP Computer Science, and all of those I recorded a few months ago and they're all posted to my channel. But one of the things that I did not go over was kind of some of the things that we had to learn that weren't actually part of some of the specific units. And one of those main concepts that we didn't actually have to learn in any of the units per se, however, was something that we needed to know for the AP Computer Science exam, especially if you end up taking the multiple choice test for the 2021 exam. That particular topic is number systems. And in this video, I'm going to be going over all of the different number systems, how to convert between number systems. And while this won't necessarily help you for, learning the programming piece of AP Computer Science, there are occasionally questions on the actual exam that will ask you to convert between different number systems. So it'll be very important for us to be able to understand how to do that so that by the time you get to the exam, you won't get those questions wrong and they'll be very easy for you. All right, so without further ado, let's get started. All right, so I am back on my tablet over here. So when we talk about number systems, just like here. What we actually mean when we refer to number systems is that number systems are basically how we represent numbers. Number systems are how we represent numbers. So now what I want to do is I want to go all the way back to like first grade and kindergarten, when you first learned how to count and how to write numbers. We're going all the way back. So pretty much forget everything that you have learned so far. We're going to be going all the way back and we're going to be talking about the literal basics and fundamentals of a number. Because that, when we're talking about number system, that's really what changes, is that fundamental aspect. So what I'm going to do is I want to write a number here on my screen. And I'm going to choose some random number. Let's say I do 1,000. So 1,742.89. Let's just say I choose this number, 1,742.89. Now, when you started learning in kindergarten or just in general in elementary school, what teachers often were to say is, the numbers are grouped into these different places, right? The ones place, the tens place, the hundredths place. So let's write that down. So you can see over here, what is the ones place in this number? Well, the ones place is right over here. This is the ones place. Then right to the left of it over here, to the left of the ones place, we have the tens place. Then to the left of this, we have the 100ths place. And to the left of this, we have the 1,000ths place. Now, or the 1,000, or the thousands place. Now, when we go to the right, so we went to the left of the number of the ones place over here, but what if we go to the right? And when we go to the right, the first number to the right is the tenths place, so 1 over 10. Instead of tens, it's tenths. Then over here, instead of hundreds, we have hundredths. It is the fraction 1 over 100 right over here. And now you may notice, and what your teachers may have told you or taught you, is that as you increase by every single place within a number, you are multiplying by 10. If you notice, 1 times 10 equals 10. 10 times 10 equals 100, and 100 times 10 is equal to 1,000. Now when you go to the right, 1 divided by 10 is 1/10. And then 1/10 divided by 10 again is 1/100, because when we do 1/10 divided by 10, this is really equivalent to 1/10 times 1/10, which equals 1/100. Just in case you were not necessarily familiar with that, 1/10 divided by 10 is 1/100. So I'm going to delete this over here. Now that we have this basic kind of flow chart of how our number works, I want you to really start to think about how everything is organized here. And if I'm going to just take another color, and I'm going to look at this tens place right over here, where the 4 is currently. Now, if I were to take this number 10, and I were to bring it down, and I were to actually convert it over into a power number or a exponential kind of situation, then what would this be? Well, this would be 10 to the first power. Now, if I were to take the number to the left of it, which is 100, and I were to write it out as a power, this would be 10 to the second power, because 10 squared is 100. Now, if I take 1000, the number left of 100, you can see that I can write this as 10 to the third power, which makes sense. You're basically increasing every time by 1 in the exponents, because 10 to the first power is 10, 10 squared is 100, and 10 cubed is 1000. But now let's go to the right. If I go to the right, well, what can number 1 be represented as? Well, number 1 can actually be represented as 10 to the 0th power, because any number raised to the 0th power is equal to 1. So 1 can be 10 to the 0. Now let's take a look at 1/10. 1/10 is actually equivalent to 10 to the negative 1 power, because remember, when you have a negative exponent, that number becomes the denominator. So you have 10 to the negative first power is equal to 1/10. Now you notice that as I go to the right, and this is 1/100th, I can write this as 10 to the negative second power, because 10 to the second, or 10 to the negative second power is 1/100th. So now you can see that I have now a scale of numbers. I have 10 to the 0, which is kind of my center point, right over here. And then I increase when I go to the left, and I decrease when I go to the right. And this time, the only thing that is changing is kind of the number, or the power of my exponent. Now you may be wondering, how does this have anything to do with anything right now? You're probably, you're looking at this like, okay, but so what, pretty much. Now I'm going to take this number here, so bear with me for a second. All of this stuff is going to connect very, very soon. If I take a number, let's just say I take any of these. This is going to be 10 to the n. Let's just say I make my exponent some arbitrary variable, because this can be anything that I want it to be. It can be 0, it can be 1, it can be 2, -3, -1000, anything I want, it can be as an exponent. So I'll make that a variable. However, my base is always 10. And that's the thing, right over here, we call this number the base. We call this number the base. And then we call this number up here the power. Right over here. So now I can take this, and I know that all of the places within my number system that we always use on a daily basis, you can take any number, and you have that ones place, 10 place, thousands place. What I can do is I can now make a new name for it, considering that we know that the base of every single place is 10. We can call this number system, right over here, we can call this number system the base 10 number system. This is the base 10 number system. What I'm going to do is I'm going to go all the way down to a second page, and I'm going to write this out. So this is the base 10 system. Now, what is the base 10 system known as? Well, the base 10 system, in kind of normal people's terms, it is known as the decimal system. The decimal system. And the key and the root here, right over here, deci, that is going to be 10. So you have decimal system. And when we look at the decimal system now, and we have these different places right over here, how many numbers, what are the possible values that can actually go within each of these places? Well, if you look at any one place, like let's say I take over here my 1/100th place, I can take this and I can say, oh, look at that, there are only going to be 10 possible values for this particular space. Now, some people may be saying, wait, what do you mean? Isn't there just 9? Well, let me list them all out over here. So there are 10 possible values. So there are 10 possible values. And what are these possible values? Well, it is 1, 2, 3, 4, 5, 6, 7, 8, 9, and 0. And it's not 10, because if I take the number 10 right over here, well, the number 10 is really 2 places. So you have a 1 in one place and a 0 in another. So 10 doesn't exist when I'm talking about the 10 possible values that can be actually placed within each place in the number. So now I have this over here, and I have this base 10 number system. But what happens if I change the base of each of the different places? So let's say I just take a random number. Let's take 2, for example. I'm going to write this out. So instead of having 10n as kind of each of my places, I'm going to change this to 2n, where now 2 over here, this is my base. 2 is my base right over here. So now let's write out a number. So I'm going to take I'm just going to take here 5 places, just like that. And now I'm going to start out with each of my different places, similar to how I did up here for a positive integer. And when I say integer, that's a number without decimal places. I'm just going to do that to make this a little bit simpler. So I take my first place. Well, in the other number system, this was the ones place, but 1 was represented by 10 to the 0 power. Now what we're doing is, instead of saying that this is going to be 10 to the 0, I'm going to be saying it's 2 to the 0. Because technically, again, I'm changing my base. So you can see over here, 2 to the 0 power is still 1. So I'm just going to erase this. This is 2 to the 0 power, which is still equivalent to a ones place. But now, just as I did with the other number, as I move to the left, this is going to be 2 to the first power. And this is going to be the 2's place. Already you can see this is becoming a little bit foreign. You probably have not seen this before. Now, what if I were to move even more to the left? This would be 2 squared now. So this would be the 4's place. Remember, the other number we had 1, 10, 100, and so on. Now we're at 1, 2, and 4. That's a little bit interesting. Let's continue on. Let's say I take 2 to the 3rd power. Well, 2 to the 3rd power, this is going to be the 8's place. And then 2 to the 4th power over here, this is going to be the 16's place. So now that we have all of these over here, let's try to take a random number. Let's say I grab the number 11. And now the number 11 is actually within the base 10 system. So if we're trying to write out what base a number is in, we write it just like that as a subscript. So this would be the base over here. What if I want to take 11, which is in the decimal system, and I want to convert it over? And I want my base this time to be in the 2's. I want 2 to be the base. So I can change this. I'm just going to write an X, and we have to try to figure out what this actually is. So now, let me take my number 11. So the first thing I need to do is I basically need to divide this by the largest number within the system. So if I take a look at this, I wrote down 11, but there could be 32, 64, 128, but the largest number that can actually fit within 11, that is going to be 8 right over here. So I can now take 11 and divide it by 8, just like that. And now I can take 8 divided by 11, and 8 divided by 11 is going to be 1. And there is a remainder, so I can do 11 minus 8, and that's going to equal 3 as my remainder. So now that I have this 1 right over here, I can put the 1 in the 8's place. And now all the numbers before it, so like this, will be 0. And technically, these places don't even have to be filled at that point. You can write 0, but it's like writing 0, 0, 16 rather than just writing 16. There's no point in doing that. So now I have my number 3, and I move on to the next place within my system. And I can divide this now by 4. Does 4 go evenly into 3? It does not. It goes in 0 times, so my remainder is still 3. So I can put the number 0 right over here in the 4's place. Now I have the number 2, and I can divide 2 into 3. And basically, 2 goes into 3 one time. So I can subtract 2 and get 1. So this is now 1 right over here. And now I have 1. Well, 1, and then my next number over here is a 1. So 1 divided by 1 equals 1, and the remainder is, 0, because 1 goes in 1 time. So I can put in the number 1 over here. And now, just like that, I have completed this entire expression. 11 to the base 10 power is equal to 1, 0, 1, 1 to the base 2, right over here. Now, this may look familiar to something you have seen before, zeros and ones. I'm going to go back to my list down here, and I'm going to be writing down the base 2. Base 2. And the base 2 system is most commonly known as the binary. The binary system. There are going to be 2 possible values for every single place. And each place, the values that can be in each specific place only, not the whole number, but just each individual place, is a 0 and a 1. Now you may be wondering that, you did this long division like this to convert this number, how would that work? And I would like to just show you the example of how we would do it in everyday life with the decimal system. If I take, again, the number 1,743, we know what this number is. But we take the first thing we take is the smallest number that will fit into it, or the largest number that will fit into it within the system. That's 1,000, right? 1,000 divided by 1,743 is just 1, right? So I subtract 1,000, and I get 743. Then I take the 1 and I put it right over here. Then I take 743 divided by the next place, which is 100, and I get 7. Minus 700, I get 43, and I put the number 7 right over here. Then 43 divided by 10, well, that gives me 4. So I can subtract 40, and now I have 3. And I can put my 4 over here. So this is 174. And then I can do 3 divided by 1, which is 3, minus 3 equals 0, and this is 3. So really, in daily life, we do the same thing. Like, the same thing works out in both cases where you do that long division to get a number. So this is in the base 10, and then this would be in binary. Binary. All right? So now I've kind of talked about converting numbers over. Now that I've done this part, I want to talk about 2 other base systems, which are common in AP Computer Science. And the next one that I want to talk about is going to be the base 8 system. So base 8. And the base 8 is known as the octal. The octal system, right over here. And the octal system has 8 possible values. This is going to be base, again, 8. So instead of having, 10n, right? This was the decimal system. I had 2n, which is the binary system for every place. Now I have 8n, which is the octal system, just like that. And so my 8 possible values, you may guess, are going to be 0, 1, 2, 3, 4, 5, 6, and 7. Just like that. Because once I have an 8, that's going to become a new number. And I'm going to take the same number 11 that I had over here, and I'm going to convert it to base 8. How do I do that? So now I'm going to take 11, base 10, and I'm going to convert it over to 8. Well, I can do the exact same thing. I can create my places. I know that this is 8 to the 0, which is 1. This will be 8 to the 1, which is 8. And now I can look at 11 and say, okay, well, 11 divided by 8 is going to be 1. So this is a 1 right over here. And so 1 minus 8, I get a remainder of 3. And then 3 divided by 1, which is my next place, gives me a remainder, or gives me 3. And then minus 3 equals 0. So I can put 3 over here. And now you look, I have a number 13 is what it looks like, but it's not 13. Because, just like how I wrote this over here, I can now say that 11 in base 10 is equal to 1, 3 in base 8. Look at that. And that's, that's actually pretty, that's pretty cool. Now, one thing that you may see in future tests is actually converting from base 2 to base 8 or something like that, where you skip the normal decimal system. I always recommend converting to the decimal system first before you convert to anything else. So now I'm going to show you how to convert backwards. I'm going to give you a random number. I'm going to give you 0, 1, or I'm going to give you 1101 in base 2, and I want to convert it over to base 10. How do I do this? Well, what I can do is I can again expand this out. So I take 1, 1, 0, 1, this, and I just kind of write out my places. This is the 1's place, the 2's place, the 4's place, and the 8's place. And again, I know this because this is 2 to the 0 power, this is 2 to the 1 power, this is 2 to the 2 power, this is 2 to the 3 power. And now I can simply multiply and add my numbers. I can take this, say 8 times 1 plus, right over here, 4 times 1 plus, right over here, 2 times 0 plus 1 times 1. And I can do this. This is going to equal 8 right over here. This will equal 4. This will equal 0. Right over here equals, and this will equal 1. And now I can just add these up. 8 plus 4 is 12. 12 plus 1 is 13. So I can say that 1, 1, 0, 1 in base 2 is equal to 13 in base 10. And that's how you convert back to whatever decimal place that you're used to. You simply can just use that method to multiply, and that works with anything. That works with even base 8 as well. And now the last thing I'm going to mention, and the last base, which is slightly more complicated because it involves something even a little bit more foreign. This is going to be the base 16. Base 16. And base 16 is known as the hexadecimal. The hexadecimal system. And the hexadecimal system has 16 possible values. So what are the possible values? So I start out with 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. But wait, what's after 9? Because once we get to 9, really, like if you think about it, we get to 10. We can't use 10 because 10, whoops, I threw my pencil onto the floor. 10 is just 2 numbers. So really, now I have to start using letters. So now I have A as representing the 10, B representing 11, C representing 12, D representing 13, and E A was 10, B is 11, C is 12, D is 13, E is 14, and F is 15. All right? So now if I were to convert my number, so I'm going to write this down here also, that's 16N, this is the hexadecimal. So now, what if I want to convert a number from, let's just say I want to take the number 30, let's see, I want to do 33. Let's take 33 in base 10 and convert it over to 16. Well, to do this, I can just simply take my 16, and I'm going to be writing it out right over here. 16 to the power of 0, well, this is the 1's place. 16 to the power of 1, well, this is going to be the 16th place. So now I can simply do division to figure this out. So I can say that 33 divided by my largest number, 16, well, that's going to equal, actually, I don't want to do 33, because if I do 33, then it won't be good. I'm going to do 31 instead. I'm kind of changing this because I want to show you something, like I want to actually use letters here. So I'll do 31. So you can see 31 so 16 into 31 is 1. And I can do 31 minus 16, which will get me 15 right over here. And I'll make sure that I did that correctly. Yep, that is 15. All right, so now that I have 15 over here, just like that, then 15, or 1, becomes my number right over here. 1 becomes my number in the 16th place. And now I do 15 divided by my next place, 1. Well, 1 divided by 15 is just 15, and that becomes, 15 divided by 1 is just 15, so then the remainder is 0, and I would put the number 15 here, but remember, I can't do that, so instead I have to do the letter equivalent. And remember, I can write this stuff down. 0, I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, because those are all my possible values. And now I can say that this is going to be, starting at 10, this will be A, this will be B, this will be C, this will be D, this will be E, this will be F. So if I want to put the number 15 here, I have to write F instead. And now I can say with certainty that 3110 will be equal to, or 31 base 10 will be equal to 1F base 16. All right, everyone, that is pretty much everything you need to know for number systems. And I'm going to be going just in a very quick review of what we talked about. We talked about the number systems refer to how we represent numbers. We talked about how we can use bases, so base 10, base 2, base 8, base 16, to represent numbers in a different way. And computers use binary most of the time inside of machine code, which is like when you go all the way down, ones and zeros are what computers understand. So everything we write is automatically converted. If you think about this, it's quite amazing. Anytime we write a number in a computer, like we write 10 or whatever, it's always converted over anyway because the computer has to use it in machine code. We talked about how to write numbers in different systems, converting from, for example, 11 in base 10 to base 2, which we did, right? Get 1011 base 2 is equal to 11 in base 10. We talked about, converting from a base that's not 10 back to base 10. So if I was ever told, for example, to convert, 101 in base 2 to base 8, right? Then how we do this, well, we take 101 base 2, convert it to a number in base 10, then take that and convert it to base 8. It's just an easier way to go through 10 rather than trying to jump and do something really, really crazy. We talked about converting the numbers again from a non-base 10 to a base 10, from base 10 to any other one, and we talked about the 4 main ones you're going to be using in AP Computer Science, which will be the decimal system, which is base 10, the binary system, which is base 2, the octal system, base 8, and the hexadecimal system, base 16. And then we talked about the different possible values for all of them, as well as going over the hexadecimal one where there are letters as well. All right, everyone, if you have any questions, definitely leave them in the comment section below, and I will try to answer all of them. I have made a lot of AP Computer Science content in the past and will continue to, especially for 2021, being a completely new administration. I may also make live streams closer to the exam date, so definitely stay tuned for that. If you like the video, feel free to like and subscribe for more content. Hit that notification bell to get notified of more AP Computer Science content, as well as potential dates for the live streams. And as always, thanks for watching and have a great day.